Hello, welcome back. Today we're going to be discussing linear regression, part 1. The objective is that we're going to determine if points from a table show a positive, a negative, or no trend using a calculator. Second thing we're going to do is, if the points have a positive or negative trend, we're going to find the equation of a line that goes through the points, again, using a calculator. To get us started, we've got a definition, which is linear regression. Linear regression is a process that finds the equation of the best fitting line to data that has a positive or negative correlation. In other words, the calculator is going to find an equation from a data table for us. Please note, again, that the data has to have a positive or negative correlation. To get us started, we've got an example. The table below shows the sales in millions of dollars for a car dealership. Determine if the following table shows a positive, a negative, or no trend when graphed. We might be able to determine if the table shows a trend without even needing the graphing calculator or needing to graph. We notice the sales are going up, the years are going up, but the sales go from 10.9 to 10.83, so going down. Then they go all the way up to 11.25. Then they go back down, then they go up, and then they go up. So it's a little difficult from just a table to see an overall trend in the data. We could graph this by hand, but there is an overall, once you get used to it, easier way, and that's going to be to graph the information in a graphing calculator. So we're going to take the following steps to graph the equation in a graphing calculator. You need to go ahead and get your graphing calculator, and the first step tells us to clear our memory. So we go second, that's the second, it's the yellow button right here, plus, go down to the plus button, it's above the enter button on the lower right hand side. That's your memory option. Notice memory, or MEM, is in yellow. 7, notice this is the memory category. We're going to go down to number 7, which is to reset. We press enter, or 1. We want to reset all of our RAM. And it's give you a warning right here. Do you really want to do this? Well, yes, we want to reset all of our RAM. And we go 2. And you should get a message that says RAM cleared. Show you again. Second, plus 7 for reset, 1 for all RAM, 2 means we really want to reset the calculator, and you get a message RAM cleared. The next thing we're going to do is we're going to take all of this data right here, and we're going to enter this data into the graphing calculator. To do that, you're going to go Stat. The Stat button is located to the right of the green alpha button. Let me show you again. Follow over from the green alpha button till you see the word stat. That stands for statistics. That's where we edit data in our calculator. And our first option is to edit. We press enter. And we have this list right here. L1 stands for our first list. L2 stands for our second list. What you need to know is that L1 is always your X value, or your independent. So we go to our data table and we see years and sales in millions of dollars. Since the sales depend on the year, that means that the year is independent and the sales is dependent. So the year is X, or L1. Which means that the sales in millions has to be Y, which is our L2 value. So these are our Y values. So let's go ahead and enter in our L1 values. To do that, notice that the first little box right here is shaded black. We're going to enter in 1999. Notice that shows up down here with the little cursor blinking. You have to press the Enter button, Enter located at the bottom right of your calculator buttons, and that makes 1999 show up in the list. Let me go ahead and type in the rest of them. 2001, Enter. 2004, Enter. 2006, 2009, and 2011. If you make a mistake, like I just did, you can always go up to your arrow keys and press the left or right arrow key to just type over what you just got through typing. So 2011. Enter. Once you have typed in all of your data, you can type the right arrow key and it'll show up on L2. Then we can start typing in our data again. 10.9, Enter. 10.83, Enter. 11.25, Enter. 11, Enter. 11.54, and 11.7. Now that we have our data in our calculator, we're going to graph this data, and to do that, you'll see at the top row of buttons on the far left-hand side is a button that says y equals, and above that in yellow is something called stat plot. That means we want to plot the data that we typed into our stat button or into our lists. So we're going to type second y equals, second y equals. Let me show you that again. You were in the stat screen, and you're going to go second y equals. Notice, number 1 says plot 1 is off. We want to turn plot 1 on, so we press enter onto plot 1. Notice that off is currently shaded in black and the cursor is blinking on on. We're going to press enter on on. What that does is that turns on all of the data that we just got through typing in the calculator. Our last step is to go zoom. That's going to set the window in the calculator. That tells the calculator what to show you when you get ready to plot your data. And the zoom option we want to choose is zoom stat. That's going to make sure that our screen shows us all the data we just got through typing in. Enter. Now what the calculator has just done for us is it's created a scatter plot. It's plotted all of our data points. What this allows us to do is determine if the data shows a positive, a negative, or no trend. By looking at the data, we can quickly recognize that from left to right, the data points are grouped together going up overall. So it is a positive correlation. Notice that I use the word positive correlation. You can also use the words, it shows a positive trend. I'll use these two words interchangeably as we discuss trends or correlations in data. We're on to our second objective, which is if the points have a positive or negative trend, we're going to find an equation of a line that goes through the points. More particularly, we're going to be finding the equation of the best fitting line, which is linear regression. So here are the steps we're going to follow in order to perform linear regression in our calculator. Make sure to turn your calculator on by pressing the on button, the lower left-hand corner. And you'll notice we're still on the graph where we started, or where we left off in the previous example. What we want to do is, since our data is already in the calculator, we're going to go back to our statistics menu, or stat. We do not want to edit it because we've already entered the data in the calculator. What we want to do is go over to the word calculate, or calc, because we want to perform a calculation on the data. And we're going to press the down arrow key until we get to the option that says len reg, ax plus b. This means we're going to be performing linear regression. And it's going to give us an equation that looks like y equals ax plus b, which is a lot like y equals mx plus b, but the m's been replaced with an a. So we press enter on our calculator, and again you notice that the cursor is blinking. This means the calculator is waiting for us to tell it to go ahead and do linear regression. We press enter one more time, and it gives us linreg y equals ax plus b, a equals 0.0697, b equals negative 128.579. Now this is not the form we're going to write when we write our equation. What we're going to do is we're going to write our equation, but we're going to round to 3 decimal places. Remember, our equation of a line in slope-intercept form is y equals mx plus b, but we replace the m and b with numbers. Well, the calculator already gives us our m, or a in this case, and it already gives us our b. So y is equal to m, or a, 0.0697, which rounds to 0.07x, plus the b value, which is negative 128.579. Now, we do not have to write it as plus negative. Typically, you'll see your equation written as y is equal to 0.07x minus 128.579. And now we've written the equation of our line using linear regression in the calculator. Here's an example for you to try. Go ahead and press pause, and when you're ready to see the answer, please press play. Alright, so the first thing you do is we need to identify what the independent and dependent variables are. So the team rank should depend on the batting average. In other words, the better the batting average, the higher the team ranked. So that means our batting average is going to be X, or L1, and our team rank is going to be Y, or L2. We're going to want to keep that in mind as we're typing in the data into our calculator. We get our calculator, turn it on, and go second plus, that's our memory option. We go down to reset, and we're going to reset all RAM, and yes, we're actually going to reset. So we've cleared our RAM, then we go stat, edit. We start typing in our L1 values, which in this case were the batting averages, 0.274, 0.274, 0.260, and we'll keep on typing those in. For the team rank, we get 4, 6, 8, and so on. I went ahead and typed in the rest of the data for us. Now it asks what type of correlation does the data show. To do that, we need to graph the data or plot the data. So we're going to go second y equals, which is our stat plot. Press enter, and press enter again, that we turned our stat plot on, and we go zoom stat. Now zoom stat will pull up all of our data in a scatter plot, and we notice from left to right the data is going down, so it is a negative trend or negative correlation. So what type of correlation does it show? It shows a negative correlation. The next thing it asks us to do is to go ahead and write the equation using up to 3 decimal places. To do that, we go sat, calculate, linear regression, press enter again, and we get our equation. Y is equal to negative 460.037 x plus 131.1496. Now the 96 is going to round up, so we need to make that 150. So there you go, we've written the equation, of the line that passes through those data points the very best possible.